Division of elements. Elements which involve the filling of a particular orbital S, P, D or F are grouped together as block. Okay, so elements are divided into S block, P block, D block and F block elements. First, S block elements. Elements in which the last electron enters into the S orbital of their outermost shell. Okay, last electron is filled in the S orbital of their outermost shell. Such elements are called as S block elements. Okay, group 1 and group 2 are S block elements. And their electronic configuration are NS1 and NS2. Okay, group 1 NS1 and group 2 NS2. Okay, they are reactive metals. They are reactive metals and low ionization energy. Low ionization energy. Okay. So first group elements are called as alkali metals. Alkali metals. And second group elements are called as alkaline earth metals. Okay. In the case of group 1, they release one electron and form +1 ion, and group 2 release 2 electrons and form +2 ions. Okay. The reactivity increases down the group. Reactivity increases down the group. And their metallic character also increases down the group. Okay. Second one is P block elements, second division. These are from group 13 to 18. Okay. In this case, the last electron enters into the P orbital of the outermost shell. Okay. And electronic configuration is NS2, NP1 to 6. Okay. Ranges from NP1 to NP6. Except P block elements are called as representative elements or main group elements. Representative elements. Okay. So different groups are group 13, boron family. Group 14, carbon family. Then 15, nitrogen family. 16, oxygen family or chalcogens. Then group 17, halogens or halogen family. Okay. 18, noble gases. These are having stable electronic configuration. Okay. Next, what about the non-metallic character? We know non-metallic character increases from left to right. In a period from left to right, non-metallic character increases and metallic character decreases down the group. So most of them are non-metals. Okay. Most of them are non-metals. Then which form ionic as well as covalent bonds? These form ionic and covalent bonds. Okay. Covalent compounds. Form ionic and covalent compounds. Okay. Third division, D block elements. transition metals. Transition elements are transition metals. They are also called as transition elements, and the group ranging from 3 to 12. Okay. In this case, the last electron enters into the d orbital of penultimate shell. D orbital of penultimate shell. Penultimate shell is the shell just before the outermost shell. Okay, so its electronic configuration. Penultimate shell, that is n minus 1, d 1 to 10, ns 0 to 2. Okay, this will be the electronic configuration. Then in this case all are metals. Okay, these are colored compounds, colored ions. Okay, these are all are metals and they form colored ions. Okay, then and variable oxidation state. They have variable oxidation state. Okay, then they are also used as catalyst. Used as catalyst. Next, three series of transition elements are there, that is 3D series, then 4D and 5D, 3 series. 6D is also there, 6D is incomplete. Okay, then transition metals have the reactivity in between the S block and P block elements. Okay. Fourth division, F block elements or inner transition elements. Here the last electron enters into the F orbital of anti-penultimate shell. What is anti-penultimate shell? Anti-penultimate shell means the orbital just before the penultimate shell. Okay. So the electronic configuration is n minus 2 and the penultimate shell F1 to 14, then n minus 1 d 0 to 1 ns2. This will be the electronic configuration of F block elements. Okay. In this case all are metals. They have variable oxidation state. Then and they are radioactive. Okay. Next, this consists of two rows which are separately placed at the bottom of the periodic table, and these two rows contains 14 elements each. Okay, and they are called as lanthanides and actinides. Lanthanides and actinides. Okay. Each row contains 14 elements, and this is the first series and this is the second series. Then in the case of lanthanides, the last electron enters into the 4f orbital, and in actinides electron fills in the 5f orbital. Okay, and elements after uranium are called as transuranium elements. After uranium, called as transuranium elements.